Welcome back, guys. In this second part of our video tutorial, we are basically talking about, some of the possible interview coding challenges, coding problems that we might encounter when we go into the interview, right? To for our, um, for our, future job or whatever. So in last example, we wrote that code, how to do decimal to binary conversion code, but as a like entry level developer or mid level developer, that question you can answer a question like that. But however, if the same question, but generally, like if you are applying for a senior level developers, right? That means at least with the company they have some expectation, like about C sharp, not only basic understanding of the C sharp, but they expect you to know object oriented C sharp. They might be asking you the same question, but you might if you are a senior level developer, if you're applying for a position in a senior level developer, expectation might be higher, because as a senior developer they will have to pay you a lot, and they at the same time they also expect you to know certain things. Let's say now you go to an interview, and there might be a question similar to this one. Let's say they might say, hey, we have this code right here that basically converts that decimal number into binary. It is all working. We have a unit test that is passing. So your challenge would be to write a number, create a class or something, so that instead of converting number into a binary, we're going to convert the number into hexadecimal. Not only that, we would like to, in the software development, code reuse is the most important thing. We want you to, as we would like to use all the possible code as much as you can. I mean, not as you can, but as you can from right here. Because let's say for some reason they're happy with the code that we have written, and they would like to apply the same kind this existing logic to build, basically convert from hexadecimal decimal to hexadecimal. Okay, let's say that is your situation. How would you and of course now you are a senior level developer. So how would you proceed? Let's look at some of the thing right here. So a conversion from binary to decimal to binary is when this number is divided by 2 in hexadecimal. When you're converting number from decimal to hexadecimal, we are basically dividing and calculating doing the modulo operator 16, and we're also doing the dividing by 16. So these two kind of changes. So based on that, let's see, we have a class already. What I'm going to do, let's go ahead and start with, let's write a base class here. Let's go some object oriented, right? Let's say I would start with creating a base class here. Let's give it a name. Let's say base number converter. Okay. We have a new class here, base number converter, and I'm going to make this class is a not instance class. I'm going to make this class abstract, meaning this, we wouldn't be able to create instance of this object. All the other classes will be inheriting from this base class. And I would start with the base class, and then I'm going to go ahead and create a new class here corresponding to decimal to binary converter. However, this time I will have a class called um, decimal to hexadecimal converter, right? That's what this class is going to do. Decimal to hexadecimal converter. Okay, now we have this class. Of course, this is going to be a concrete class, and this class will be inheriting from the base class that we just created right here called base number converter. Base number, of course, right now in our abstract class, we don't have any So right now in there, let me go ahead and save everything right here, okay? And after that, let's look at the our challenge is like, they would like to reuse this code as much as possible. So this code right here, even this is a code written by the company people, and I'm gonna, instead of having this code here, I'm gonna grab this code and put this into our base class. Into let's hold our method. Let's grab this one. I'm going to copy this code and put it into the base. And I'm not going to make this as and then it's going to be a protected class, and I'm going to make this class virtual. um, yeah, the if you do not have background in object-oriented programming, by making this class as a virtual, the inheriting classes will have option to override. If they would like to provide the totally new implementation, this would allow it. Basically we can override that implementation. Okay, let's fix this one. I'm missing something. Okay, so we started refactoring, because they have a class here, and now we have convert to binary in this. Okay, no problem. In here, instead of having this implementation right here, so next thing we're going to do, we also would like to inherit this from our new abstract class, base number converter. Okay, and then we have virtual class. We don't have this class here, but we can say we have that virtual class. We can override this one here, and then oh, sorry, that it is a public. I made that protected. That's why it is complaining about. Let's make it public. Okay. Okay, now it's happy because it was a protected method, but I have here is a public. So I made that method in the base class also public. Okay, and now I'm basically overriding here. I can override it, but just by looking at this one right here, we can now think about how we can use this class. So okay, even before that, let's go into our test here. And now instead of here referring to well, let's build this core project here. It builds. Okay, rebuild succeeded, and let's build a whole solution. Instead of, when I declare this private field right here on line number 13, instead of declaring it as a concrete offset, now I can declare it as a base number converter. Okay, and then this is an abstract class, but when I create the instance, I'm going to say decimal to binary converter. That's what it is, right? And then we are basically refactoring little by little. Okay, let's go ahead and make sure this test passed, because that was a running test. We modified some code, and we have to make sure that we didn't break anything. Okay, all our tests are passing. That is good. Okay, now if you look at into, let me close everything here. Well, right now it only works for the binary number, but our goal is to this whole code right here. Any other like hexadecimal conversion, or maybe later on we might write how to do octal, octodecimal to octal conversion, or whatever, octable number format conversion. We should be able to utilize all of these. So just by looking at this one, instead of hard coding this value right here, we're going to use object-oriented feature here. Since we are, so what are we going to do here? We're going to define, let's write down protected. We're going to make abstract. Let's give it long, okay? We could, well, I was going to say integer number format. Uh, format. Let's say a number format right now. Just a getter. So into the base, so what we have done here, in a base we have an abstract, a property called number format. This abstract means all the inheriting class must, unlike virtual which is optional, this abstract means they must implement, provide the implementation to this property called number format. So at this point, I cannot run it because if I try to run this one here, it is failing. The reason is because we are these two classes, decimal to binary converter, inheriting from here, but in the base we have this protective property. So hey, you must provide the implementation. That's what they're complaining about. Let's go ahead and provide the implementation here. Okay, just go ahead, just say implement the abstract property. So since it's a decimal to binary converter, all we can do right here is we're going to return number 2. That's all we have to do. So now we don't need this anymore because we can be using the base here, right? um, so instead of we're just going to say return, we're going to say base, and we're going to call the base method here and pass this decimal number that comes out as a parameter to this function. Okay, we have to do one more thing in the base before we can start implementing. So now we go into base here, and then right now we are hard coding value 2. Instead of hard coding, we're just gonna say this dot number format, and we can also gonna change this one by this dot number format. Okay, let's make sure. Well, at this point, it's not going to run. We have one more class here called decimal to hexadecimal converter. In here also, because it has we have to implement that property called number format. Let's go ahead and do that. In here, as you can say, as you already know, it's just going to return 16. Return 16 because we are trying to convert the decimal number into hexadecimal format. Okay, if you don't remember, the algorithm is basically instead of dividing by 2, when we convert to binary, we'll be dividing by number 16. Okay, so far so good. I think if I build this now, our unit test for the binary should be working. Let's make sure we haven't broken anything. Where is our unit test here? Okay. Okay, pretty good. All our unit tests is green. We haven't broken anything. We are basically slowly refactoring and trying to reuse the code. Remember, originally they asked us to, hey, write the modular code. Of course, we haven't written our implementation of hexadecimal yet, but we are going slowly. We are refactoring slowly by slowly, and we are basically trying to reuse all the code as much as possible. So now into here, we base number converter and hexadecimal converter. So just like in here, let's override this method here, convert to binary. and we right away call the base. Okay. However, and now we have, decimal to hexadecimal converter. Let's go ahead and write a unit test, because we always want to make sure we have a unit test going. And here is, we have decimal to binary converter. Let's kind of control C, can create a new one, and basically rename it. I'm going to rename this as a decimal to hexadecimal converter test. It's a test class. We have decimal to binary converter test, and we have decimal to hexadecimal converter test. And of course, we have to have the same name here. That's why it is complaining. And the constructor. And here, instead of we are creating here instance of decimal to binary converter, it has to be the instance of decimal to hexadecimal converter. Okay. Why it is hexadecimal converter? This is cannot create let's see, something is wrong here. Converter. It's a public class decimal to hexadecimal converter. Okay, maybe it's not built or something. Let's go make sure it builds. Okay, that is okay. Base number converter. Base number converter. No, I don't want to do that. Why you can? Something is wrong here. Decimal to binary converter. Decimal to hexadecimal converter. And this guy is also inheriting from base number converter. I don't understand why I cannot create instance of this. Go to definition. Decimal to hexadecimal converter. It's the constructor here. Something is okay. Let me go ahead and when I did a copy and paste, something happens. I'm gonna go ahead and delete this one. Let's do it properly. I'm gonna go ahead and add a new class called decimal to hex converter, and it's a test class. And one more thing I would like to do is, in Visual Studio, I'm going to make sure I enter it as the unit test class, so that we'll have basic template automatically. Okay, so here in the like before, we can define a private read-only base number converter. Let's do a name resolution here, and we can define variable called hexadecimal converter. Okay, converter. So in the constructor, we're just going to create the instance of new hexadecimal converter. I don't know what happened before. I mean, so that's what all I did. And right here, let's write some unit tests here. Refactor this, give it a name. I mean, change it this name to um, test decimal to hexadecimal. Okay. All right. Some unit tests here. Oh, my spelling to that method. We'll change it later. And I need to find some, decimal number in the web and this. Okay, let me see. That's not what I want. Hexadecimal numbers. Okay, so let's find some hexadecimal number. This, okay. I need some number for the unit test, guys. That's what I'm looking for. That's why I'm going to the web. Okay, here this guy has some example here. All right, let's see. Okay, it's a 14. 14 should be E. Okay. I expect to have E whenever I pass hexadecimal, convert to binary, and I pass 14. Okay. So this is our very first test. So basically I'm saying, all right, I expect to have the value E, okay, that way for the decimal value 14 when I run this test. Of course, at this point, it's not going to run our test. It's going to be, we'll have failure here. It is, it says misses are equal. I was expecting E, but actually it was 41. Okay, there is something we have to do. If we go into decimal converter right here, decimal to hexadecimal. So when you divide a number by a 16, you will have a remainder, possible remainder from 0 to 15. 0 to 9 is already been covered. So now we have to consider 10, 11, 12, 13, 14, and 15. And those are represented by character A, B, C, D, E, F. If that's how the hexadecimal number works. So to be able to do that, before you see right here, before we add this remainder into the our model number builder here, we need to have a virtual this one we can accomplish by something like this. I'm gonna expose protected virtual method that's gonna return a string, and I'm gonna say format, and it's gonna take, for now, listen, let's take some sort of number here. Okay, you will see why I have decided to do this one here. So I'm gonna, as into the base class, I'm gonna provide the default implementation right here. The default implementation, all I'm gonna do here, number, and I'm gonna convert that into toString. So even though it's a very trivial method here, it's a virtual method. It's very important to understand why I did this one here. Okay, and then the number comes in, and all I did here in the base, convert that number into a string. Okay, so to this remainder, I'm going to say format. Before I put that into my number builder, I put that into a formats right here. Okay, but however, this is all I do here in the base, but and this is all I have to do when it is a binary conversion. But however, in the case of hexadecimal conversion, I have to consider all those cases. So here I'm gonna basically override that method. Override. Come on. Override. This format method we would like to override in our if in we're gonna override this method in when we are converting from a binary to hexadecimal. Let's write down some basic switch statement here. Okay. Just say a result for now, and the switch is a number. If it is 10, then the result would be, A. If the remainder is a remainder, that's that number is basically a remainder. If it is 10, the result would be A. And we're gonna break from here, and let's consider all the possible cases here. Three, four, five, six. If it's 11, if it's 12, if it's 13, if it's 14, and the last one is if it is 15. And as you know, so if it's 11, it'd be 11, then we can write down B. If it is 13, that would be C. Okay, that should be D, and that should be E, and this one's finally should be F. And then, but otherwise, the default, the result should be, that's a string, so I'm going to say a number into a string. Break. Okay. And then all we have to do is just return that method here. So the beauty about this one is this is all we have to do to be we reuse a lot of code, their existing code, and we were able to provide the feature. We didn't break their unit test, and we provided some object-oriented feature to this problem. And all the additional code that we had to write in this case is basically here right away. We just call the base here, and just we had to override this format, and we had to override this property here. If let's first make sure this builds okay. I have all whole project built successfully, and now we have our unit test here. If this pass, we right now we have we just have one test. We're gonna write, yay, awesome. And at the same time, let's go ahead and run all the tests here. Okay, we didn't break anything. We want to make sure we didn't break all the tests right here: decimal to hexadecimal conversion, and test convert to binary. That's for our binary conversion, and this is the by default Visual Studio Create. I don't need this one. This is all good, but our unit test is not good enough. Um, so let's do some additional testing here. This is 3, 4, 5. So we know. Let's see decimal 1000. Decimal 1000. If I remember correctly, it should be something like 3 E8 or something. Let's comment those three and make sure it is correct. Yeah, that the pass. So a lot of this, I don't know. Maybe I will have to. Looks like our implementation is correct because it's passing. Let's see. What would be the 10,000 decimal equals to? It will tell me because this unit is definitely not E because E is equals to 14. So if I run this test, I should have a failure here. And one test is failure. It says, okay, you know what? You were expecting E. That's not correct. That it is a 2710. Okay, 2710. That looks good. How about 100,000? I don't know. Just play with it. 1,000, 10,000, and 100,000. Uh, Run this test. Okay, so another failure here. So expected value for the 100,000 is 18680. 18680. And let's do a last test here for 1 million. 100, 1,000, 10,000, 100,000, 1 million. Okay, let's run this. And of course, we don't know what the value is. It fails, and it is telling us, right? It's a F4, F4240. That is a hexadecimal representation of the 1 million. Okay, at this point, just to recap what we did, they asked us to, write very modular code by reusing their existing code base and try to refactor along the way, make code very nice and make sure the unit test is passing for existing class, and also unit to and then create the unit test for the new class that we wrote. At this point, everything is good. We can invite those people, hey, I have done the implementation, and they start looking at your code and they see, I mean, like, they see your code, what you did, and I'm pretty sure if you can do something like this, I would guarantee you they would hire you. Definitely. I mean, like, of course, of course, the technical side, but of course, to be able to hire, you have to not only technical side, you have your background check, all those things. If you have already satisfied all the precondition, unless there is an even better candidate than you are. I mean, in most of the places when they're usually they would have really awesome candidate, 3 4 candidate out there, and I don't know if there's somebody comes in and does it much better than you did, and even like efficient way, unless they have there's only one candidate and that's it. Chances of you being hired is a lot. Anyway, guys, I mean, there is so many ways you can solve problem like this, but I'm just trying to show you, this is the approach you can take, or whichever method you feel confident. Anyway, my goal is to how a same problem can be solved based on your expertise, based on the type of job and type of level of job that you are applying for. Anyway, I hope my teaching would help somebody, somebody who is doing interview and stuff. Definitely find job. All right, thank you so much for watching this video, and this would be we'll have additional question like this and in different kind of problems. All right, guys, thank you so much for watching videos.